Welcome to qnawire.
We are given that the scuba tank was filled up to 180 atmospheres of pressure at 20 degrees Celsius, and it had a volume of 11.3 liters. Now, how much air, how much air is in it at normal pressure, which is 1 atmosphere and 20 degrees Celsius? That's the question. For that, we know that PV by T is equal to NR, which is a constant, which means P1V1 by T1 is equal to P2V2 by T2, giving us, because temperature is the same in the two cases, we know V2 is simply P1V1 by P2. We know that initial pressure is 180 atmosphere divided by the final pressure is 1 atmosphere times the initial volume is 11.3 liters, which gives us 2034 liters. Now for part B, we know that we take 2 liters of air per breath and we breathe 12 breaths per minute, which means the volume of air we inhale in a single minute is simply 2 times 12, 24. As you notice, the units when you multiply the units, the breaths will cancel, giving us liters per minute. So now that we have 2034 liters, the amount of time it will sustain us is simply 2034 divided by 24. Notice the units, liters and liters per minute. Our liters get cancelled, and our answer is simply 84.75 minutes, which is about 85 minutes, or 1 hour 24 or 1 hour 25 minutes. Now, for part C, the deep sea diver is at 20 meters depth in the water. We know that at that depth, the pressure is the initial atmospheric pressure at sea level plus rho GH, where rho is the density of salt water, g is the acceleration due to gravity, and h is the height. Now, we use the same formula again. Also remember that the temperature is 10 degrees Celsius. So P2V2 by T2 is equal to P1V1 by T1. In this case, we can't cancel the temperatures as we did in the last problem, which gives us P2 is equal to, V2 is equal to, that is, the volume of the air now would be P1V1 by T1 times T2 by P2. Now, we know that the initial pressure P1 is 180 atmospheres, and we know that each atmosphere is 1.01 times 10 power 15 pascals. 10 power 5 pascals. Times the volume was 11.3 liters divided by 293 Kelvin, which corresponds to 20 degrees Celsius. T2 is 10 degrees Celsius, which corresponds to 283 Kelvin, divided by the pressure now, the new pressure is, as we know, P naught plus rho GH. We know that P naught is 1.01 times 10 power 5 pascals, which is 1 atmosphere, plus we know that rho, the density of water, is 1.025 into 10 cube kg per meter cube times 9.8 is g, and we know that h is 20 meters. This whole thing, when you substitute into a calculator, turns out to be 657.2 liters. Now this would be the volume of the gas if it got out of the scuba equipment. So simply doing the same calculation as the problem part B, given that we use 24 liters per minute, how long will it last us? That would be 657.2 divided by 24, which turns out to be 27.38 minutes, which is 27 minutes almost.